Tonight, while you sleep, something strange is going to happen. Your body will go completely still. Your muscles will be chemically paralyzed. Arms, legs, face, all of it locked down by your own brain. You will be, for all practical purposes, unable to move. But your eyes will keep going. Did you know behind your closed eyelids, your eyes will dart left, right, up, down, tracking something, moving with purpose, following a scene that only exists inside your head. And for 70 years, nobody could fully explain why. The story starts in 1953, in a sleep lab at the University of Chicago with a broke graduate student named Eugene Ozarinsky, who was running out of ideas for his thesis. Sleep research at the time was about as interesting as watching someone lie still for 8 hours, which is, of course, exactly what it was. The dominant scientific belief was that the brain essentially idled during sleep. Quiet, passive, off. Ozarinsky didn't have many research subjects, so he started watching his own son sleep. And he noticed something that nobody had documented before. Several times throughout the night, his son's eyes would begin moving rapidly beneath his eyelids, darting around, fast and deliberate, as if watching something. Then it would stop. Then it would start again. He told his supervisor, Nathaniel Kleitman. Kleitman was skeptical enough that he made Ozarinsky repeat the experiment on his own daughter before he believed it. But when they wired sleeping adults to an early electroencephalogram and monitored their eye movements, the data was undeniable. Multiple times every night, every person they studied entered a phase of sleep where their eyes moved rapidly, their heart rate spiked, their breathing quickened, and their brain lit up with activity nearly identical to the waking state. They published their findings in Science in September 1953, 1.5 pages. It quietly launched the entire modern field of sleep medicine. They called it Rapid Eye Movement Sleep, REM. And the question that immediately followed was obvious. What are the eyes actually doing? The leading hypothesis was that they were scanning dream imagery, that your eyes were physically tracking the things you saw in your dreams, the same way they track real objects when you're awake. It made intuitive sense, but for decades, it couldn't be proven. When researchers woke sleeping subjects and asked where they were looking in the dream just before waking, the results were contradictory. Half the studies said yes, the eyes follow the dream. Half said the movements were random. The debate went unresolved for nearly 70 years. Then, in 2022, researchers at UC San Francisco found a way around the problem of asking humans to report their own dreams. They studied mice instead. Mice also experience REM sleep. And they monitored something called head direction cells. These are neurons in the brain that function like a compass. When an animal is awake and moving through an environment, these cells track exactly which direction the animal is facing. They are essentially a live map of where the creature believes it is in space. During REM sleep, those same cells were firing, and they were perfectly coordinated with the eye movements. When a mouse's eyes moved left during REM sleep, the head direction cells indicated the mouse was oriented left, inside its dream. The eye movements weren't random. They weren't lubricating the eyelids. They were tracking a virtual environment that existed only in the sleeping brain. Your eyes, while you dream, are watching the dream. They believe it is real. They are behaving exactly as if what they are seeing is actually there. These eye movements aren't random, said Massimo Scanziani, the study's senior author. They're coordinated with what's happening in the virtual dream world. But now we have a second question. If your eyes are moving, if your brain is generating a vivid, convincing, fully navigable world, and your eyes are tracking it in real time, why aren't you running through your living room, acting the whole thing out? The answer is one of the more unsettling things your body does without telling you. While you dream, your brainstem sends a flood of chemical signals, specifically the neurotransmitters GABA and glycine, that physically switch off the motor neurons controlling your muscles, your arms, your legs, your torso, paralyzed, on purpose, every single night. The system is called REM atonia, and it is so aggressive that your brain uses multiple overlapping mechanisms to make sure it works, because the consequences of it failing are serious. There is a condition called REM sleep behavior disorder, where this paralysis doesn't engage properly. People with this condition physically act out their dreams. They punch, kick, run in place, shout, fall out of bed. They injure themselves and their partners, not because they are violent people, but because their brain failed to lock their body down. What makes this condition particularly sobering is that REM sleep behavior disorder is now recognized as one of the earliest detectable indicators of Parkinson's disease. The same region of the brainstem responsible for triggering REM paralysis is one of the first areas damaged by the disease. sometimes decades before any other symptoms appear. So, while you sleep peacefully tonight, your brain is running a complete simulation, a world with locations, movement, visuals, narrative, and your eyes are scanning it just as they would scan this room. Your brain knows the simulation well enough to move your eyes through it correctly. And simultaneously, a completely separate system in your brainstem is making sure the rest of you stays still, using redundant chemical locks built specifically for this purpose, because your brain has correctly assessed that if you were free to move, you would act on what you're seeing. Your brain trusts the dream enough to watch it. It just doesn't trust you not to believe it. Every night, without your knowledge or permission, you watch a film only you can see, paralyzed in the dark, your eyes moving through a world that doesn't exist. The only question science hasn't fully answered yet is what exactly the dream is for, and that one might take another 70 years.